Hi everyone, welcome back to another tutorial on AutoCAD. So today we're going to handle this beautiful sketch. Here you can see there is a lot of angles which set up in different direction with a lot of confusion maybe that you have right now. But I can assure you this is pretty much easier even you are a beginner, and you're going to learn at least 3 different models or 3 different types or 3 different methods that you can use in AutoCAD to manipulate angle. So after this session, you can decide yourself which one is suitable for you, which one is really easy for you. So let's begin. So this sketch, you can see it start from point A. So before that, let me check which template that I'm gonna use. So I have to use the A3 template for this one, and the unit is in millimeters. So let me open module template A3 from my computer. Here you can see this is my A3 template. Click on that, it will open into AutoCAD. Just wait, yes, it's loading. Now we know that the units are in millimeter. For this template it's already set up, but we can make sure, just go to units and see this thing should be in millimeters. And once it's in millimeter, just put OK. So now everything that we are drawing on this template will be in millimeters. So let me check the questions. This is the beautiful sketch that we're gonna make. So we know that it is start from point A, and which is given the x coordinate is 300 and y coordinate is 200. So let me take 300, 200, and A to B I have to use how much? 30 mm. So from A to B it is 30 mm. So start from 300, 200, take the line. So now start from 300 x comma 200, enter. So we got the start point, and ortho mode is already on, and these lengths we know that this is 30 mm. Just enter. That's it. So we managed to finish the starting part. And now from B, we have to draw an angle 140 degree downwards, that is in clockwise direction. And the length of BZ here, it is 45. So the length of BC is 45 and the angle is 140 degree. So here I would like to show you a new thing which I didn't mention in my previous video. So here, if you use my previous technique of finding a 3 o'clock line, I mean the 0 degree line, and if it goes clockwise direction, you're gonna put this thing as negative 140 degrees so that it will take in a clockwise direction and you will get that line. That's it. But there is another way in AutoCAD. Without thinking whether it is clockwise or anti-clockwise, whatever the direction it goes, you can make use of this technique, which is called polar tracking. Now let me introduce polar tracking first, then we will deal with the question. So over here you can see the toggling option for polar tracking, and I'm gonna turn on polar tracking. And if you're not seeing this option here, go to customization and make sure the polar tracking is selected on this list. So let me check this one. So if you go to polar tracking, here you can see a small arrow, just click over there, and here you can see there is different series. On the top you can see 90 degree, 180, 270, that means it's a 90 degree series, and down there it is 45. You add up 45, you will get 45, 90, 135 and keep going. So it is 30 degree series, and here you can see 15 degree series, even we have 5 degree series. So let me show you how it works. If I take the line and if I turn the polar tracking on, and let me zoom in so that you can see, if I snap from here, start from here, and here you can see the angle on that small gray box, and the length is coming in another box in blue color. So as now just focus on the angle. So this is our 3 o'clock 0 degree line. If I move in this direction, here you can see there is a tracking line is coming. The tracking line is the green dotted line that extending away outward to this template. You can see this green line. This is what I called tracking. Now you can see it start from 0 and you move up, it track on 5 degree, then it track on 10 degree, then it track on 15 degree. Why? Because you chose the 5-degree series. In case I choose 10-degree series, what's going to happen? This is 0 and I move, it is track on 10, then it track on 20. You can see that green line is coming 20 degree, and when it reaches 30, I mean 10 more, here you can see again the tracking. So every 10 degree it will tracks. That is what happens. For example, one more, let me take 45 degree. So what happened? 0 degree, it shows the tracking. When you reach 45, it's gonna track. See, automatically it will track you. And when it become 90, that is one more 45 degree, it will track. Now you move here this way, you see on 135 degree, it track again. That every 45 degree you will get tracking across this 360 degree. So that is how polar tracking is working. So get back to our problem and let me show you how we can make use of that one. So here we need 140 degree. So it's obvious that if you go for the 10 degree series, you can track 140 degree. So let me take the 10 degree series. So 10, 20, 30, it will track that way. And I'm going to take the line. So make sure your polar tracking option is on, and I'm on 10 degree and I'm starting from here. So starting from point B, I'm going to make 140 degree, right? So this is my point B and start from here. This is 0 degree. Now you can see if you move down, keep down, you can see every 10 degree it is tracking. Once it become 140, so this is the angle that we want. So here you can see this is the angle that we want. So what is the length? The length of BC is 45 mm. So you have to remember that one. So you track up to 140 and now you simply put 45 mm and enter. So what is the advantage here? Here you're not putting the positive, negative or whatsoever. You don't need to check whether it is goes clockwise or anti-clockwise. No more headache. Just track the angle, put the value that you want, and you are good to go. So that is how this thing works. So let me continue and come back here. Now we're gonna make CD. The length of CD is again 45 millimeter. Since it's a horizontal straight line, so I'm gonna make 45 by turning on ortho mode. Otherwise you can go for 0 degree and do the same, but the easiest way is use the ortho mode. I'm gonna put 45, enter. So we managed to make it. Now get back to this. Here again I'm gonna use the polar tracking. So from here I'm gonna make 125 degree from D to E. The length is 60 mm, which is given on this table. So we want 125 degree. So you turn on this polar tracking. If you need 125, it's better use this 5 series. I'm gonna use this 5 series and start from here. We're gonna move 125 degree and the length of that line is 60. So start, this is 0 and keep moving. Every 5 degree it is tracking. You can see every 5 degree it is tracking. So when it is 125, I'm gonna put this is 125. The length I want is 60, just enter. That's it. Now you managed to make an angle 125 degree with a length 60 mm. So polar tracking is pretty much easier than the basic method that you learned in previous video. So keep this in your mind. Whenever you see an angle, it's better use polar method. So in case you need a specific angle, so here you can see all the series are available. In case you want to make a series of 60, for example, which is not available here. So you can click over here, track settings, and you will see this symbol and just click on new, and here you can enter 60 and that's it. And now put OK. So when you check here now, you can see you have 60 degree series. So what happened? You can track 60, 120, 180 like that. So whatever you want, what kind of angle that you want to make, you can create your own series, then you can do it. But by default, usually you will get this kind of angles up to 10 series, 5 series and all, which is pretty much enough to handle most of the question. So now get back to our sketch, and right now we are at point E. Now I would like to teach you one more lesson. Even though you're using polar tracking polar tracking is always work from your 3 o'clock. So the 3 o'clock problem is always there. For example, you are drawing from point D. That means this is your 3 o'clock line. And this angle will measure in this direction or this direction. So whatever the direction that you go, it always starts from 3 o'clock. Even this angle, this is your 3 o'clock 0 degree line. This starts from here. So whenever you draw an angle, it starts from 3 o'clock. So what happens if we use the same technique to draw 150 degree, this angle, you have to imagine your 3 o'clock line right here. And you start your polar tracking from this 0 degree line. And even though you use polar tracking, it's gonna start from this line. So you cannot directly input 115 on AutoCAD. Instead of that, you're gonna find this angle and then you sum these angles together and you can draw it. So it is not a difficult task if you know the basic geometry behind all these things. It is manageable, but I would like to show you some advanced technique that you can use. So why it is always start from 3 o'clock? Just because the entire table is already defined with a coordinate system X and Y. So right now this is your coordinate system and this is your origin 0, 0. You know that the Cartesian coordinate system start from 0, 0 and it move in X direction and Y direction. So what we're gonna do here, so if you using the global coordinate system or the world coordinate system as per the AutoCAD terminology, that is the original coordinate that you use, it is always count from the X direction, the X axis. That means if you take this coordinate system and you're gonna put it over here, let me show you how that look like. This is the theory behind this idea. So let me take my coordinate system into this point E. So this is my X coordinate and this is my Y coordinate. So what happens if I move my coordinate system up to here? Now every point I define hereafter, this is my 0, 0 origin and everything that I can start from that coordinate. So this extra coordinate that you define is what we call user coordinate system or UCS. Sometimes it called as the local coordinate system. So in AutoCAD it called as UCS, user coordinate system. So this is the idea behind it. Now if you want to measure angle 115 from this line, what we're gonna do, your x-axis should be in this direction. What I'm talking, instead of putting your X and Y coordinate this way, I'm gonna make little difference. So I'm gonna rotate my x-axis. I'm gonna rotate my x-axis in another direction. For example, whenever you draw an angle, put your x-axis across the line that you're drawing. So I'm gonna put my x-axis in this direction. And my y-axis is obvious, 90 degree from x-axis will be in this direction or maybe it will move downwards. So this is my x and y axis. So instead of putting x and y axis in a same manner of world coordinate system, I'm gonna tilt the coordinates in this manner. So what's the advantage of you doing this? So if you do this way, your angle will measure from this x coordinate. So you can start from here. That means this will be your 0 degree. If this one is your 0 degree, now you can easily put 115 on AutoCAD. Then it will directly give you this line EF. So maybe you got little confused. Don't worry. I'll show you how this thing really happens with AutoCAD. Now take the AutoCAD and go to your command box and just type UCS. And here, first you have to select the UCS icon first. So let me type UCS, and here you can see UCS icon. The second option, just enter, take it, and UCS icon you have to click here on. If you turn on UCS icon on the left side, now you can see the coordinates X and Y, right? So now I am going to move this coordinate system to this point so that I can manipulate the angle. Now once you turn on the icon, type UCS again. Now you're going to choose the first command, UCS, enter. Now you can see the origin is coming with my mouse, so I'm going to fix it here. So first there is 3 clicks that you have to make to fix the coordinate. So first you snap on the endpoint, just click. Now you have to fix the X direction. So always you can see the track line is coming with X. So always make sure your X is along the line. So put the X direction there. Now to put Y, so it is coming, you can see the green line is coming there. Your Y, just click there. So forget about the Y, the X should be along the line. Now what we're gonna do, come back to the question, and this is EF is 60 mm, EF is 60 mm. Let me mark it here. This is 60 mm at an angle 150. So the advantage of defining UCS, you don't need to calculate anything. You can directly put your angle. So this is 150 because your X coordinate is right now along this line. So you don't need to calculate anything. So 60 at an angle 150, right? So I'm going to take line. Now start from here. So when you see this symbol over the mouse, this green line and red line, it means you are on your UCS coordinates. So I'm going to start from here, just click. And as usual, the length of line is 60. And you can use the polar tracking. So I'll show you how you can use the polar tracking along with the UCS. Now you can see your 0 degrees from this line. So previously it was from here, the 3 o'clock. So now it is from this line, so that when you move, it will track your line. So the angle that we want is 115. So make sure your polar tracking is with a 5 degree angle, so that it will track every 5 degrees, 0. And it's keep going, 135 is what we need, 100. So let me check. Sorry, we need 115, right? So from here is 115. Now you can see on your polar tracking 115. Now you can put the length 60, enter. So that's it. We managed to finish it. So once you're done, escape, and now you have to return your coordinate system back to origin. So I'm gonna type UCS again and enter. Now here you return your coordinate system into back. So here you can see the world coordinate system, that is the original coordinate system. Just select world. So if you select world, now you can see your coordinate is back on its previous position. Now let me take the drawing again. Now we are on point F. So I'm going to use the same method, the UCS method, to draw this 120 degree. Now you will learn it in a better way. So 120 degree, what I'm going to do, I will take this coordinate and put the coordinate X along this line, Y over here, so that I can calculate 0 degree from here towards the direction that I want. So I'm going to type UCS again. So UCS icon is already turned on, so you don't need to turn this on again. So type UCS, enter. Now your coordinate is coming. First we will fix the origin. Now we're gonna make x-axis along the line. You can see this is the line. Just click, it will be along the line. Now fix the y coordinate over here itself. Just click, done. Now I'm gonna take the line. Now you can see the x-axis is along the line. It is in this direction already. So 120 degree, that is what we want. At 115 degree. So if it is 150, make sure you are on 5 degree series. Okay. And the length is how much? FG. FG, you can see it is 45 millimeter. So the length is 45. The angle is, 120 degree, right? So the angle is 120 degree and the length is 45. So if it is 120 degree, I thought it is another one. So take 120 degree, it's better choose 60 degree series, right? So either you can use 30 degree series, 120 is coming here. So I have 60 degree already created. So let me use this one, 60 series, and start from here. Take the line, start from here, and you can see this is your 0 degree, and automatically if you move 120, it will catch there. So once you saw the tracker, you see every 60 degree, you can see the tracker, that green line, and the length is 45. So it is 120, it will track, see, 120 it tracks down, and the length is 45, type it, enter. So now we finished, and escape. Once you finish, it's a good practice to type UCS again, and choose back to your world coordinate system. Just select the world. Now you can see the coordinate is back. Now we're gonna make this GH. The GH, we know that it is 90. It's given on the table. And the angle from FG is 115. So I'm gonna make the coordinate over this point G, and I make the X coordinate along this line so that I can easily put 150. No more calculations here. So let me type UCS, enter, and the coordinate is coming with my mouse. Click. Now I'm gonna make X coordinate along with this line. Click, and Y is obvious, it's here. Now I'm gonna check line. So check back 115 at a length 19. So to get 115, I'm gonna use the 5 series. So start from here, take the line, start from here. So here you can see this is 0 degree, and if you move every 5 degree, it will track. So on 115, it's track, and the length that you want is 90. So once it track 115, yeah, then 90, the length, enter. Now you see how easily we manage it without any calculation. This is the advantage of user coordinate system. So once we finish, I'm going to type UCS again and return my coordinate back to the world. Click world. So it will come back. Now it is back to normal. You can continue with the question. So from H to I, it is very easy. It should be 120, and you can see it's horizontal straight line. So the easiest way, go for the easiest way, turn on ortho mode, take the line, start from here, this direction, 120, enter. We finished. Now what we're gonna do, we have to make this 120 degree. So actually you can use the world coordinate system and use your system to handle this 120 degree. You make your x-axis in this direction along the line, and then you're gonna draw 120 degree. And then you can find this length IJ. Okay, let me show you how you can use UCS on this particular case. So always remember your X coordinate should be along the line that you're drawing. So right now we are on point I. This should be the direction of your X coordinate. So I'm going to type UCS again. And now the coordinate is coming with me. Put your coordinate system right here, and now your X should be across your line. Just click, and while it will be here. So this is the setup that we are going to start. Take the line, turn off the ortho mode for drawing angles. It should be 90 mm. We're going to take the line, start from here, and this angle is 120 degrees. So here you can see this is your 0, and if you need to track 120, go to polar tracking, make sure you turn on polar tracking, and to get 120 degree, I'm going to use this series 30, 60, 90, 120 series. So this is your 0 degree. Make sure where is your 0 degree all the time, and if you move this direction, when it reach 120, that is what we want, and the length is 90 mm, enter. So easy as that. Now once you finish, it's better take UCS back to its origin. I'm going to choose world. Now UCS is returned. Now this part is nothing, just join JA. So take the line, start from here, join JA, escape. That's it. So we managed to finish the sketch. So the catch here, in previous video you learned how to draw angle in AutoCAD. by using the basic. But in this video, I taught you how to use polar tracking as well as how to use user-centered coordinates. So the advantage of user-centered coordinate here, you no need to do any calculation. Just redefine your coordinate system across the line that you're drawing the angle, then take that as the 0 degree angle and just put what is available on the sketch. That is the advantage of UCS. Okay, I hope you understood this thing. You can comment over the video for more information and check the link in the description for exclusive video on manipulating angle in AutoCAD. So as always, thank you for watching. Keep your work up.